Hello everyone, we are Group 3 from bsais 2B. Today, we're going to discuss a topic 4, which is the tools of TQM. There are 7 tools of TQM that we're going to discuss. But before we proceed to the reporting, let me introduce first my groupmate. So we got Mila Rose Dizon, siya po ang aming editor or yung nag-compile ng aming video reporting. Then meron kaming 7 reporters. First is si Aira Mae Vispo sa A part po. Next, si Zea Casapao, B part. Si Jamaica Jaravata sa C part. Mary Jane Laude po is sa D part. Michelle Francisco, E part. Karin Famenia, F part. And sa last, si Domincil sa G part po. Okay, so let's proceed to the reporting.
Hi, my name is Aira Mae Vispo. Today I will discussing about the check sheets. Check sheets. Check sheets is a data recording form that has been designed to readily interpret results from the form itself. It needs to be designed for a specific data. It is gathered used for the collection of quantitative and qualitative repetitive data, adaptable to their different data gathering situations. Minimal interpretation of results required, easy and quick to use, no control for various forms of bias exclusion, interaction, perception, operational, and non-response estimation. Here's are some example of check sheets. When to use a check sheets. First, when data can be observed and collected repeatedly by the same person at the same location. Second, when collection data on the frequency or patterns of event problems, defects location, defect causes, or similar issues. Third, when collecting data from the production processes.
Good day, everyone. May this day be filled with new knowledge for us to be capacitated and innovative. Hi, everyone. My name is Zea Alyana B. Casapao. I have chosen the topic about the scatter diagram.
What is a scatter diagram? The scatter diagram graphs pairs of numerical data with one variable on each axis to look for a relationship between them. If the variables are correlated, the points will fall along a line or curve. The better the correlation, the tighter the points will hug the line. This cost analysis tool is considered one of the 7 basic quality tools. Scatter diagram is a powerful tool to draw the distribution of information in 2 dimensions, which helps to detect and analyze a pattern relationships between 2 quality and compliance variables as an independent variable and a dependent variable, and understanding if there is a relationship between them, so what kind of the relationship is weak or strong and positive or negative. The shape of the scatter diagram often. When to use a scatter diagram? When you have prepared numerical data, when your independent variable may have multiple values for each value of your independent variable, when trying to determine whether the 2 variables are related, such as when trying to identify potential root causes of problems, after brainstorming causes and effects, using a fishbone diagram to determine objectively whether a particular cause and effect are related, when determining whether 2 effects that appear to be related both occur with the same cause, when testing for autocorrelation before constructing a control chart. A scatter chart works best when comparing large numbers of data points without regard to time. This is a very powerful type of chart and good to show the relationship between 2 variables. There are procedures to follow in using a scatter diagram to attain the best results and answer, and these are: number 1, collect pairs of data where a relationship is suspected. Number 2, draw a graph with the independent variable on the horizontal axis and the dependent variable on the vertical axis. For each pair of data, put a dot or a symbol where the x-axis value intersects the y-axis value. If 2 dots fall together, put them side by side, touching, so that you can see both. Number 3. Look at the pattern of points to see if a relationship is of use. If the data clearly form a line or a curve, you may stop because variables are correlated. You may wish to use regression or correlations analysis now. Otherwise, complete steps 4 through 7. Number 1. Divide points on the graph into 4 quadrants if there are x points on the graph. 2. Count x over 2 points from the top to bottom and draw a horizontal line. Next is count x divided by 2 or over 2 points from left to right and draw a vertical line. And the last one is if the number of points is odd, draw the line through the middle point. Number 5. Count the points in each quadrant. Do not count points on a line. Number 6. Add the diagonally opposite quadrants. Find the smaller sum and the total of points in all quadrants. A is equal to points in upper left plus points in lower right. B is equal to points in upper right plus points in a lower left. And letter Q is equal to the smaller of A and B. N is equal to A plus B. Number 7. Look up the limit for N on the trend test table. If Q is less than the limit, the two variables are related. And if Q is greater than or equal to the limit, the pattern could have occurred from the random chance. An example is given here. The ZZ400 manufacturing team suspects a relationship between product purity or percent purity and the amount of the iron measured in parts per million or ppm. Purity and iron are plotted against each other as a scatter diagram as shown in this figure. There are 24 data points. Median lines are drawn so that 12 points fall on each side for both percent purity and PPI. To test for a relationship, they calculate A is equal to points in upper left plus points in lower right is equal to 9 plus 9 is equal to 18. B is equal to points in upper right plus points in lower left equals to 3 plus 3 equals to 6. Q is equal to the smaller of A and B is equal to the smaller of 18 and 6 equals 6. N is equal to A plus B equals 18 plus 6 is equal to 24. Then they look up the limit for N on the trend test table. For N is equal to 20, the limit is 6. Q is equal to the limit. Therefore, the pattern could have occurred from random chance and no relationship is demonstrated.
As you can see in the diagram, there were 24 data points.
Let's not take into considerations the following. The first one is even if the scatter diagram shows a relationship, do not assume that one variable caused the other, but may be influenced by a third variable, so that the relationship may or may not constant. The next one is when the data are plotted, the more the diagram resembles a straight line, the stronger the relationship. Next is if a line is not clear, statistics N and Q determine whether there is a reasonable certainty that a relationship exists. If the statistics says that no relationship exists, the pattern could have occurred by random chance. Next, if the scatter diagram shows no relationship between the variables, consider whether the data might be stratified or rearranged. The last one is if the diagram shows no relationship, consider whether the independent x-axis variable has been varied widely. Sometimes a relationship is not apparent because the data do not cover a wide enough range. We must remember that scatter diagrams cannot give us the exact extent of correlation. It doesn't show a quantitative measurements of the relationship between the variables. It only shows the quantitative expressions of quantitative change.
That's all. Thank you for listening.
Good day, learners. I am Jamaica Jane Jaravata. For today's topic, we are going to talk about the cause and effect diagram, or also known as fishbone diagram. Let us start with what is cause and effect diagram. The diagram's purpose is to relate causes and effects. Visual representation used to find out the cause or causes of a specific problem. It is a diagram that maps one or more causes to one or more effects. Instead of jumping to some actions to solve the problem, the cause and effect diagram allows exploration of possible causes. This may lead to a better solution to the problem. Cause and effect diagram is applied in defect correction in products and services. There are three basic types. First, dispersion analysis. It involves identifying the potential cause for a specific quality problem. Second, the process classification. It involves establishing causes related to process. In the manufacturing industry, both the type of diagrams are using, but dispersion types are most frequently used to identify the potential causes of the quality-related problems. And last, the cause enumeration. There is slightly changes as compared to above both types. Simply list all the possible causes first and then draw the chart in order to relate the causes to each other. Cause and effect diagram has a variety of benefits. First, it helps team understand that there are many causes that contributes to an effect. Second, it helps graphically display the relationship of the causes to the effect and to each other. And last, it helps to identify areas for improvement. Now, let us see the cause and effect diagram, that it looks like the bones of a fish. You start with the problem or effect, which would be the head of the fish. Starting from the head of the fish, you draw different bones, one for each category of the causes that could generate the effect. There are quite a few options for these bones. Most common is man, machine, materials, and methods, or also known as 4Ms. This fishbone diagram can be defined as a visual tool used to identify, explore, and visualize all the possible causes related to a problem. It helps to find the root causes of the problem. This method can be used in a group, and it is helpful if you need to tackle problems on your own. Fishbone diagram is also known as Ishikawa diagram from the name of Kuro Ishikawa, who popularized it. It also known as the cause and effect diagram. Let's take an example. A company has a recurring defect on the whole diagram. It is decided to tackle the problem through the fishbone diagram. The facilitator organizes a cross-functional work group that works in a room with the help of a large whiteboard to draw the fishbone diagram. The problem is placed in the head of the fishbone, which is diameter out of tolerance. The 4Ms are written on the 4 bones of the fishbone: man, method, machine, and materials. The facilitators ask each member of the group to write down the possible causes of the problem on post-its. The post-its are subsequently collected by the facilitator and with the help of the group are placed in the appropriate category. In case there are duplicate causes, they are considered as possibly more relevant as contributing to the problem after this brainstorming. The facilitator leads the discussion to decide with the group the causes that are considered most influential on the generation of the problem. The simply voting method can be used for this phase. Typically, 2 or 3 main causes are selected and countermeasures are proposed for these causes. In this example, we can imagine that the team decided to focus on these 3 root causes. Conclusion: the fishbone diagram is a simple and inexpensive tool to find the root causes of a problem, align the team, and involve everyone in the resolution. It is very important to have an experienced facilitator who can guide the group through the problem-solving process. The more the team will practice applying the fishbone diagram for problem-solving, the faster and more effective it will become.
Hello everyone, I am Mary Jane Domincil Laude from bsais.
This is the continuation of topic 4. I am going to discuss the Pareto chart, one of the tools of total quality management. So let's start it from the history. This is Wilfredo Pareto, who introduced the Pareto chart or Pareto principle. He was an Italian civil engineer, sociologist, economist, and philosopher who was born in 1848 in Paris. He was the head of political economy in the University of Lausanne. And there's why he was like economist and engineer. That's why he introduced something, and that was that 20% of population owned 80% of property in Italy. And this principle came in any kind of discipline after he first introduced. This subsequently, people in various disciplines and professions noticed that the same 80-20 rules applied in many disciplines like business, in accidents, and in quality. Joseph Juran, he was an American engineer and quality management consultant, and he named it the Pareto principle because he noticed that the 80-20 rules can be applied in the quality issues. That's why he named it Pareto principle and also called 80-20 rule. What is Pareto chart? Pareto chart is a graph to identify and plot problems or defects in descending order of frequency. The sequence starts from the number of the problems that occur the most to the problems with the least frequency. It also indicates the frequency of defects as well as their cumulative impact. In graph, it is indicated by the highest graph bar or far left to the lowest graph or far right. Uses of Pareto chart. First is to identify the one or two situation categories in which most of a problem occurs. To focus attention on the major contributing factors and to show progress in quality improvement projects. And this the example of Pareto chart of defects in shirts, where in far left is the frequency of occurrence in the highest graph bar, and far right is the cumulative percentage and to the lowest graph. So a Pareto chart is a combination of bar graph and a line graph. Each bar usually represents a type of defect or problem. The height of the bar represents any important unit of measure, often the frequency of occurrence or cause. The bars are presented in descending order from tallest to shortest. Therefore, you can see which defects are more frequent at a glance. And the line represents the cumulative percentage of defects. That's all.
Hello everyone, my name is Michelle H. Francisco. Today, I am going to discuss the flow chart, a process diagram. What is a flow chart? A flow chart is a picture of the separate step of a process in sequential order. It is a generic tool that can be adapted for a wide variety of purposes and can be used to describe various processes. The example of flowchart is this. Basically, ang flowchart, they are graphical representation or images represents the sequence or the arrangement ng isang operations. Then yung flowchart rin po is ginagamitan natin ng different symbols or shapes which I'll be discussed later. When to use a flowchart? To develop understanding of how a process is done. To study a process for improvement, to communicate to others how a process is done, when better communication is needed between people involved with the same process, to document a process, and when planning a project. What are the symbols used in flowchart? So for the symbols, we have the following: terminal block, process block, input-output block, decision block, initialization block, connectors, and flow lines. Flow lines indicate by straight lines with arrows to show the directions of the flow. Used to connect the blocks by exiting from one and entering another. So, yung flow lines po is they are lines with arrowheads para maipakita po ang direction kung ano po yung next step nung pupuntahan ng data. Look at the image po. That is the example of flow lines. Next is terminal block. Ovals or rounded rectangles are used to indicate the start and the end of a module or program. So, from the word terminal block, ito po yung symbol na ginagamit para sa termination o start ng ating algorithm o flowchart. So, we have these two, the start and the end. So, basically, from the word start, doon po magsisimula yung flowchart. And the end is last or the ending point of flowchart. Next, we have initialization block, used for declaring, initializing variables needed to solve a certain process. So, we have a word declaring and initializing. So, pag sinabing declaration, stating a variable name to use. Then, sa initialization naman is to set a starting value of a variable. Para po maintindihan natin, meron tayong example dito. So, this is the example of declaration. If you're going to observe, meron tayong num1 and num2. Wala silang values. So, sinasabi mong kailangan mo yan later doon sa process ng algorithm mo. Then, next is initialization. So, dito sa initialization, meron na siyang value. Sinasabi mo na ang kailangan mo sa num1 is 5. Sa num2 naman is 3. So, that's the difference between the two. So, next, we have process block. The rectangle indicates a processing block for such things as calculations, opening and closing files, and so on. Okay, so from the word process block, ito yung processes o actions na ginagawa natin. So, we have this example below. Meron tayong num1 at num2 kanina. Remember? You want to calculate their sum. Gusto natin makuha yung sum ng dalawa. So, we have sum equals num1 plus num2. So, don't forget rin po na isa lang ang enter at exit point ng process block. We have input-output block. The parallelogram indicates input to and output operations. So, this is the example of input and output block. Okay, you are going to observe the input. Meron siyang get x for the input. You can use verb get or enter input. Okay, so those are the variable that you can use inside input block. And for the output block, you can use the verb display and print. Next, decision block. The diamond indicate a decision. It has one entrance and exactly two exit from the block. One exit is the action when the resultant is true and the other exit is the action when the resultant is false. So for the decision block, we have this. If you're going to observe, isa lang yung arrow na papunta sa condition. Condition is a questions or statement that gives you an answer of true or false or yes or no. Yung mga condition natin is question or statement na sasagutin or bibigyan ka ng sagot na true or false or yes or no. Example, masaya ba mag-accountancy? Yes or no. Mahirap ba mag-accountancy? Yes or no. So, that is a condition. Then, next, you're going to look at the decision block. Meron po siyang dalawang exit point which is the true or false. Okay, so for the true or false, it can be any symbol. It can be a process block, input-output block, or terminal block. So, the convention or the questions that can be answered or given under conditions, we have true or false, T or F. That is the same with true or false. Yes or no, or Y or N. Same with yes or no. Lastly, we have connectors. The circle is used as a connection point between two sections of a flowchart that are not adjacent or closely located to each other. Yung connector po kasi is ginagamit para i-connect yung blocks na medyo magkalayo. So for example, nagsusulat ka ng flowchart mo, then hindi siya nagkasya sa papel or sa pinagsusulatan mo. So gagamit ka ngayon ng connector para ma-connect mo yung dugtong ng flowchart mo doon sa ibang part ng papel. But we have this note. Connectors should be used as little as possible. As much as possible, dapat hindi tayo gumagamit ng connector, okay? This should only use to enhance readability. Ginagamit lang siya para malinis tignan. Kasi syempre, ang pangit naman tignan kung dami mong lines na paikot-ikot. Meron ring negative effect pag parating ginagamit ang connector. So that's all, guys. Thank you for listening.
Good day everyone, I'm Famenia, and for today's lesson, I'm going to discuss the histogram. What is a histogram? A histogram is a graphical representation that organizes a group of data points into a user's specified ranges, similar in appearance to a bar graph. The histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into logical ranges. Histogram is a kind of bar chart showing a distribution of variables or causes of problem. In short, a histogram is a bar chart, especially in TQM. It shows the frequency of a cause of a problem occurring where the height of the bar as an indicator of the most affecting reason, and also a histogram is a popular tool to analyze a large amount of data. The histogram can help you represent frequency distribution of data clearly and concisely among different groups of a simple, allowing you to quickly and easily identify areas of improvement within the process of the structure. Similar to a bar graph, each bar within a histogram represents a group, while the height of the bar represents the frequency of the data within the group. Histograms are particularly helpful when breaking down the frequency of your data into categories such as age, days of the week, physical measurement, or any other category that can be listed in chronological or numerical order. The next is the part of a histogram. So we have 4 parts of a histogram. The first part is a title, the second part is the x-axis, the third part is the y-axis, and the last part is the bars. The title describes the information included in the histogram, while the x-axis are intervals that show the scale of values, which the measurements fall under. The y-axis shows the number of times that the value is secured within the interval set by the x-axis, and lastly is the bar, so the height of the bars shows the number of times that the value occurred within the interval, while the width of the bars show the interval that is covered for a histogram with equal bins, so that the width should be the same across all bars. Next is the example of a histogram. So here are the scenario. Ai is the branch manager at a local bank. Recently, Ai has been receiving customer feedback saying that the wait time for a client to be served by a customer service representative are too long. Ai decided to observe and write down the time spent by each customer on waiting. Here are his findings from observing and writing down the wait time spent by 20 customers. So the corresponding histogram with 5-second widths are 5-second intervals would look as full second. We can see that there are 3 customers waiting between 1 and 35 seconds, and there are 5 customers waiting between 1 and 40 seconds, and there are 5 customers waiting between 1 and 45 seconds, and there are 5 customers waiting between 1 and 50 seconds, and lastly, there are customers waiting between 1 and 55 seconds. So AI can conclude that the majority of customers wait between 35 and 50 seconds. So the last is the histogram shape. The first is a normal distribution. In a normal distribution, points on one side of the average are is likely to occur as on the other side of the average. So the next is bimodal distribution.
In a bimodal distribution, there are two peaks in a bimodal distribution. The data should be separate and analyzed as separate normal distributions. The next is the right skew distribution. A right skew distribution is also called a positively skewed distribution. In a right skew distribution of a large number of data, values appear on the left side with a fewer number of data values on the right side. A right skew distribution usually occurs when the data has range boundary on the left-hand side of the histogram. For example, is a boundary of 0. So the next is a left skew distribution. So a left skew distribution is also called a negatively skewed distribution, and in a left skew distribution, a large number of data values occur on the right side with the left number of data values on the left side. A right skew distribution usually occurs when the data was a range boundary on the right hand side of the histogram. For example, is a boundary such as 100. The last is the random distribution. A random distribution lacks an apparent pattern and has a several peaks. In a random distribution histogram, it can be the case the different data properties were combined. Therefore, the data should be separated and analyzed separately.
Hi everyone, my name is Elvinson Domincil. Today, I will discuss the statistical process control chart. What is statistical process control chart? The control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a central line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are determined from historical data. By comparing current data to the lines, you can draw conclusion about whether the process variation is consistent in control or is unpredictable out of control, affected by special causes of variation. This is the example of statistical process control chart. Control chart, also known as a Seward chart or process behavior charts, are a statistical process control tool used to determine if a manufacturing or business process is in a state of control. It is more appropriate to say that the control chart are the graphical device for statistical process monitoring.